So we talked about vertical asymptotes and how that's where the denominator equals 0 after factoring and canceling. We talked about wholes. That's going to be x values where the denominator equals 0 in the beginning of the function, but then after canceling, we can now plug that in and we're not dividing by 0 anymore. So the other very important special type of thing that might appear with rational functions are going to be horizontal asymptotes. So let's take a look at how do we find horizontal asymptotes. So vertical asymptotes, that had to do with the denominator equaling 0. Horizontal asymptotes instead is going to be looking at the degree of the numerator and the denominator. So remember, in a rational function, the top and the bottom, these are both polynomials. And remember, the degree of a polynomial, that's the highest power of x that's present. So when we look at each of these, we can always look for the highest power of x. So there's going to be three possibilities. If the degree of the numerator is larger than the degree of the denominator, something's going to happen. If the degree of the numerator is going to be less than the degree of the denominator, so the degree of the denominator is larger, what happens? And then what if they're both the same? So we're going to look at these three examples to help us understand what happens in these three instances. So in this first one, we see that the degree of the numerator is 1. Highest power of x is 1. The degree of the denominator is 2. The highest power of x is 2. So here, the denominator has the higher power of x. So the degree of the denominator is larger than the degree of the numerator. So we're going to be looking at this case where the degree of the numerator is smaller than the degree of the denominator. And here, if we look at the picture, remember the horizontal asymptote, that's what's happening when x goes to infinity or negative infinity. It's the finite number that's being approached, if there is one. And so here it is approaching a finite number, it's approaching 0. So in this instance, we have y equals 0 is the horizontal asymptote. So no matter what, if the degree of the denominator is larger, then we have y equals 0 be our horizontal asymptote. We saw the same thing with the function 1 over x. That had a horizontal asymptote at y equals 0. Now if we move on to this example, this now, if we look at the degree of the denominator, it's 2. The degree of the numerator is also 2. So these have the same degree, same highest power of x's. And so if we look at this example, well, this is also a funny looking function. This has no vertical asymptote. The denominator will never equal 0 for any real values of x. But this, if you notice, it's still approaching a finite number as x goes to infinity and x goes to negative infinity. So in this case, it's approaching the number 7/3. Now, why does 7/3 appear? Well, if you look at this example, we have a 7 and a 3 appear. So these had special names. For a polynomial, the coefficient in front of the highest power of x, we call that the leading coefficient. So when we have the powers are the same, we look at the leading coefficients to tell us what the equation is of our horizontal asymptote. So when these are the same, we're going to have y is equal to the leading coefficient divided by the leading coefficient. And if we'd like to be more particular, we can say the leading coefficient of the numerator divided by the leading coefficient of the denominator. So you simply pick out those numbers, the leading coefficients, and that is exactly what forms our horizontal asymptote. Now this last instance here, now the degree of the numerator is larger than the degree of the denominator, so the top's taking over. To have a horizontal asymptote, our function has to be approaching a finite number as x goes to infinity or negative infinity. Here, this looks more like what the polynomials do that we saw. When x goes to infinity, it seems to be going up and up and up and up. It doesn't seem to be approaching a finite number. Same thing in this direction, our function is going to keep going down and down and down. So in this instance, we're not approaching a finite number, so there is no horizontal asymptote. So in this case, if the degree of the numerator is larger than the degree of the denominator, this says that there is no horizontal asymptote. So we have these three instances. So any rational function that I give you, as long as you remember how to find the degrees of the numerator and the denominator, you should be able to find the horizontal asymptote as long as you remember these three rules.